Hi and welcome here in Produal Academy. My name is Antti Salli and I'm a product manager for our wireless products. Today we will take a look how to design mesh network. So let's hop in. The VBU is our heart of the wireless network and all the transmitters are connected to the VBU. VTRs are drawn here like this. So now we have all the VTRs and how the mesh network is working is so that we have a certain area that the VBU can cover. And the VTRs that are nearest of the VBU are so-called root nodes that are connected directly to the VBU. And in this case, these 4 VTRs would be the so-called root nodes that are connected to our VBU. These VTRs are now expanding the wireless network so that the other VTRs that can hear these root VTRs are connecting like this. So this is a basic principle of the mesh network. Each transmitter or the device in the network is expanding the coverage of the wireless network. How this is differentiating from the point-to-point network is that if we would have a point-to-point network, the gateway need to hear or the transmitter need to hear the gateway. Meaning that if we would have a transmitter here, it need to have working connection here to here. But now when we are operating the mesh network, each transmitter in the network is expanding the coverage. This makes possible that we can build up a network from tens of meters to up hundreds of meters. It doesn't matter in what direction. Usually we recommend that the VBU is placed middle of the network to get the best possible structure for the wireless network. Because then we can build up so-called star network where we have multiple so-called these root nodes connecting directly to the VBU. By doing this, it gives us more resistance for network failures. That means, let's say if we have a transmitter dropping from the network. So we are losing now this one root node connection and this transmitter is dropping from the network and the transmitters behind of that. But because we have a mesh network, what it will do is that this might be in the same area or the coverage area of the VBU, and it makes a connection and then build up a connection behind of that. Or it can even come from here. It doesn't matter because all the transmitters are working actively and repeating the messages in the network. Each transmitter has this main connection that is using. So based on the signal quality and the factors of connection, it is using a selected transmitter. But each transmitter always keeps up a list of other nearest connection points. Like in this case, this VTR was connected to this one, but it always knows what other transmitters is in its own coverage area. And in this case, this VBU was the second best selection for the connection point, and that's why this VTR connected now to this VBU. One thing that differentiates Produal Proxima Mesh system to many other systems is that we can run this system as a fully battery operated. Every battery operated VTR can work as a repeater for the network. What this means is that we can build up the network without any external power supply. Comparing to many other or competing systems is that those need to have external power supply for the routing nodes. But in our system, all the battery-operated transmitters works as a repeaters. Like I was saying, the star structure for the mesh is best and optimal. But of course, that's not possible to every time to make it so. So let's take a look on how we can build up reliable network without making it as a star type of network. I will now take an example of normal apartment building. Here I have an example of apartment building where we have a wireless network. The optimal place for the gateway is always in the middle of the building, but that's not possible usually to put there Example, in this case, if we have an apartment building, the technical spaces are in the top floor or in the basement. So usually where we need to put the gateway is on the basement floor. Now we have put it VBU here, and when we start to design a network, we should take account those first transmitters that we are adding near of the VBU. If we think about that, what we need to measure, we need to measure the example temperatures from the apartments in this case. So we are placing VTR to each apartment. But in this case, what is the connection point is so that usually now the nearest transmitter is connecting to the VBU and it's making a mesh network like this. But where is the risk is that if we lose the connection to here, we lose whole network. So to design a network so that we have a more resistance for failure situations would be something that we add also transmitter here in the basement that would create another road for the wireless transmitters to build up the network in the situation where we lose the connection to the nearest transmitter. Of course, this is not always possible, but this would be good to take account when designing the wireless network for this type of buildings. Also, one thing that I want to talk about is the frequencies and technologies that we are using in the Proxima wireless system. We have a VBU, and VBU and VTRs are communicating using mirror mesh communication protocol. That means that all the transmitters that are in the mesh are using so-called mirror mesh. This is a mesh protocol for transmitters and gateway to communicate together. When we are doing configuration and installation of the network, we are using Bluetooth. Bluetooth is supported by the MyTool and all the transmitters. MyTool can communicate with the gateway and with the transmitters by using a Bluetooth. All of these protocols are using 2.4 gigahertz frequency. In the gateway and the transmitters, we can operate mirror or Bluetooth, but not in the same time. What this means is that when we are doing a configuration of the gateway or the transmitters, we need to do it over the Bluetooth. But when we are running the Bluetooth, the mirror mesh is not working. After we have done the configurations, we can turn the mesh operation mode back and the transmitters will reconnect to the gateway. We are using also so-called beacon data in our MyTool. So beacon data is one-way information sent by all the transmitters and the gateway after the installation. When the MyTool is receiving these beacon packages, it can create different kind of views and show information from the transmitters and the gateway. Example, during the installation when we have a signal scanner, all of these signal strength values is built based on these beacon messages that are sent by the transmitters and the gateway. MyTool is something that we can use for a signal scanning. All of these transmitters and gateway is sending these kind of beacon messages. And those beacon messages we can receive with the MyTool and use that also to measure signal quality. This is shown as a decibels, and recommendation is for installations is that the decibel level should be 98 or less decibels when we are making installation and searching best place for the transmitter. After the transmitter has joined to the network and there is a working mesh connection to the gateway, we are measuring so-called packet loss ratio or mesh link quality. And this is something that we can see from the Modbus registers of the VBU. And this should be 35% or over after the installation is done. If these values, example, this is under 35, level of 25 or something, that means that our signal quality between two transmitters is too weak and there might come some kind of a problems. Same thing is here with when we are doing these decibel measurements with the MyTool. If we go over 100, that means that the transmission power of this transmitter where we want to connect is too low, and the final connection might be too weak to have a proper communication between the transmitter that we are installing to this one. There is many things that we should avoid when we are designing and building up the mesh network. One thing is that when we are designing a network, let's say in the office building, and I draw here a floor plan of the office. We can have elevator shaft, we have walls for different kind of rooms. Then we can have pillars, concrete pillars. And now when we are placing a VBU, of course, we want to put center as possible to have a best possible connection. And in this case, we don't have the possibility, so we need to put it on technical space, the VBU. And we want to place transmitters all over the office building to here, 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 and let's say here. What is our problem in this kind of installation is that we need to take account that there is a big concrete pillars and one elevator shaft that are affecting to our signal. We can see that if we place the transmitters and the gateway optimally, we can have working connection like this. But here to this one we don't have. And the challenge is that it's too far away from here. If we build up network so that these transmitters can build up a connection like this, we don't have a problem. But this regards that we install enough VTRs to this floor plan. If we, example, don't have this one here, then we have a challenge to get a working connection to these two transmitters here in the back corner. Usually when we design the network from the floor plans, it is good to check, is there elevator shaft, different kind of pillars, metal pillars, concrete pillars, and what is the construction material of the walls. If these are like, example, glass walls, glass is the material that can block radio signals quite good, and it makes hard to get working connection over multiple glass walls. So, example, in this case, if we are not installing transmitter here, having example transmitters in these places, it might give us more possibilities to expand the network. Also, it's good to remember that if we have an example here, a pillar, and we install transmitter this side, the signal might not penetrate the pillar to the backside, so the signal can be heard only in this area. So this kind of things is good to check when you are doing the mesh network planning from this kind of floor plan that you have before you are going to make the installation. Of course, if you have a possibility to go on the site and use our signal scanner or our pre-scanner tool to check the possible places for coming transmitter, that will make much easier when the final installation is done. So we just take a look on how to make a floor plan of the wireless network. It is also good to understand how the wireless network is working in verticals. What I mean is that usually, like I was previously saying, the gateway is coming somewhere in the bottom part of the building or top part. And when we are doing the design of the wireless network, one thing is that if we are installing example transmitter here, what it needs to do, it needs to penetrate this concrete block in 95 or 45 degrees angle, and that makes more harder to get the signal penetrating the concrete. But when we have a transmitter here, we are going straight through this concrete block, and it's a little bit easier for the radio signal go in straight lines versus if we need to go on these kind of angles. Also, when we are designing a network, it is very good practice to make so-called lines. So each floor has transmitters so that they are top of each other, and this makes more reliable connection from floor to floor, and these transmitters can then expand the network to these floors. Sometimes it's not possible to have example all the floors the transmitter, But in these cases, you need to be very cautious how you are doing the installation, because if you are putting so that there is no transmitter between in this floor, I recommend to check the radio quality from this floor to here. Also, in many buildings, there is these called maintenance shafts that are open from bottom to top. These are very good places to install routing transmitters, example like this. So here there is no block for the radio signal, and these can then share the radio signal for the transmitters in the different floors. This was a short introduction of how to design Produal wireless network and how to avoid problems after you have done the installation. I hope this was helpful, and see you in upcoming Produal Academy episodes.